Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In this class we are going to study the last concept in carbonyl compounds, that is carboxylic acids. Carboxylic acids are the class of organic compounds in which the functional group has a carboxyl group that is bond C double bond OH. This is the functional group of carboxylic acids. Why we call these group compounds is carboxylic acids? Because here there is two functional group, one is carbonyl group and one is alcoholic group, that is carbonyl group and alcoholic group, that is hydroxy group. Okay, so that by combining these two we call as hydroxy, that is carboxy compounds, means COO, this carboxy plus this hydroxy, we called as carboxy, that is carboxy compounds. Means the carboxylic acid function group containing both hydroxy group as well as carboxyl group, so that by combining these two we called as carboxy compound, that is called as carboxylic acids. Here the functional group is C double bond OH. This is the bond C double bond OH is the functional group. Then the general representation of these carboxylic acids is C double bond OH. This is the general representation, where R is nothing but alkyl group or halide group. If alkyl group is nothing but H or CH3, so on, etc., it means this R is either hydrogen or any alkyl group. Then halide group means aromatic groups. This is the introduction of this carboxylic acids. Now we are going to study the first class of carboxylic acids is called monocarboxylic acids. Then now the first class of carboxylic acids is monocarboxylic acids. Here monocarboxylic acids are the carboxylic acids in which the compounds containing only one carboxylic group, that is COOH group. The general representation of these monocarboxylic acids is COOH. Here R may be either hydrogen or any alkyl group or any halide group. Okay, such resultant compounds we called as monocarboxylic acids. Now these carboxylic acids are acidic in nature. Due to the presence of one acidic proton. This is here there is a hydrogen, right? This hydrogen is acidic in nature. So that the given monocarboxylic acids or any carboxylic acids is acidic in nature. And these are the then these monocarboxylic acids is called as fatty acids. Then the naturally occurring monocarboxylic acids are citric acid and tartaric acid. These monocarboxylic acids is also called as what? Fatty acids means long chain hydrocarbon along with acid group we called as fatty acids. Then the naturally occurring fatty acids are monocarboxylic acids are citric acid and tartaric acid. This is the introduction about the monocarboxylic acid. This is the representation of monocarboxylic acid. Monocarboxylic acids are the carboxylic acid which having only one COOH group. Here R is either hydrogen or any alkyl group, any halide group, and these are acidic in nature due to the presence of one acidic hydrogen. And is also called as fatty acids. Then naturally occurring carboxylic acids are citric acid and tartaric acid. This is occurring orange or lemon etc. fruit, orange or lemon fruits means. Okay, now we are going to study the nomenclature of carboxylic acids. Now, nomenclature of carboxylic acid. You know, when in nomenclature there is two systems. One is common system or trivial system. Then the second one is high-pack system. One is common system or trivial system, and the second one is high-pack system. In common system or trivial system, the name is given based on the compound which is obtained from that source. For example, the formic acid is the first acid. So you know the functional group of carboxylic acid, that is COOH, and the general representation is COOH. In place of R, I write hydrogen, the first compound you get. This is called as formic acid. Formic acid. This formic acid is obtained from formicose, that is red ants. This is obtained from red ants, that is from formicose. Then similarly, the second compound CH3 COOH. This is called as acetic acid. In the common name, we are called acetic acid. This is obtained from acetum, means vinegar. That is acetum. Acetum means vinegar. From vinegar, the compound is obtained. In Latin called acetum, so that the name has acetic acid for this compound. Like that, we are giving the common name. Now observe one more example: butyric acid. Butyric acid means 4 carbons. There is CH3, CH2, CH2, bond COH. This is butyric acid. This butyric acid is obtained from butter. So the name has butyric acid. Like that, we are giving the common name based on which is obtained from their source. Now, in the high-pack system, the last letter of an alkane, he is replaced by writing oic acid. Then the resultant compound is named as oic acid, like that. That is the high-pack system. For example, observe, if there is a compound like HCOOH, that is called what? Formic acid. Now, for example, if there is a methane, CH4, what is name in alkanes? The high-pack name is methane, right? Now, in high-pack system of carboxylic acid, here there is one carbon, hence we are named as meth is a root word, and being alkane we are writing ANE is a suffix. Similarly, in this compound there is only one carbon, so that the root word is meth. And being an alkane, see here there is no double bond between carbon and any substituent of this R group. So that it is also in a alkane, that is ANE, that is methane. Now here this he in an alkanes is replaced by writing oic acid, oic acid. This is the compound name of this one. That is meth plus ANE plus oic acid, that is called as what? Methanoic acid. This is the high-pack name of this compound. Similarly, observe this one is the second compound, that is called acetic acid, which is obtained from vinegar. How many carbons are there here? 1, 2. 2 carbons, it means the root word is heat. Being an alkane, we are called as ANE, that is ethane, right? Now here the functional group is COOH, right? So that the last letter E is replaced by writing oic acid. So the resultant name of this compound is ethanoic acid. Okay. Similarly, now observe if there is a 3 carbons. For example, here one of the hydrogen is replaced by writing CH3 group. How many carbons are there here? 1, 2, 3. If 3 carbons is there in a given compound, then we call root word is prop. Being an alkene, we are writing ANE. Propane, right? in alkane E is replaced by writing oic acid. Oic acid. Why we are writing oic acid? Because the functional group is COOH. Hence the name of this compound is propanoic acid. Here we are including the carbon which is present in the functional group also, right? So 1, 2, 3 carbons, hence we call as propanoic acid. Similarly, now name this one. How many carbons are there here? How many are there? 4. 1, 2, 3, 4. So if there is 4 carbons, what is the root word? Bute. And being alkane, ANE. So he is replaced by writing oic acid. What is the name of this compound? The IUPAC name butanoic acid. Okay, like that we are giving the IUPAC name for a given carboxylic acid. It is very easy and simple, students. Now take some examples to give IUPAC name and also the common name. Observe, students, here we are taking some examples. The first one is HCOOH. What is its name? How many carbons are there? Only 1 carbon. So coming to IUPAC name, in IUPAC name there is only 1 carbon, so that the root word is meth. Being an alkane, AN. He is replaced by writing oic acid. So what is its name? Methanoic acid. Already we are discussed right now. Now the common name is what? What is common name? Formic acid. Why we are giving formic acid as common name? It is obtained from formicus, called red ants. Means the name of red ants we call formicus in Latin language, so that we call as formic acid. Similarly, the second one, what is its common name? Acetic acid. Because it is obtained from vinegar or acetum, that is called acetic acid. Then the IUPAC name is how many carbons are there? 1, 2. So 2 carbons means heat, and being an alkane, ANA, and he is replaced by oic acid, that is called ethanoic acid, right? Now similarly here 1, 2, 3 carbons, so that the common name is also propanoic acid. Propanoic acid, and the IUPAC name is also same, that is propanoic acid. For 3 carbon compound of carboxylic acid, the both IUPAC name as well as common name is same. Now here take the fourth one. 4 carbons are there. What is its common name? Butyric acid. Because it is obtained from butter. Then second one means the IUPAC name for this one is butanoic acid. Butanoic acid, right? Now observe here, this is the compound which containing 2 function group. One is hydroxy group and one is carboxylic acid group. Now its common name is called as lactic acid. Remember, this is the structure of lactic acid, is the common name. Now the IUPAC name is, give number 1, 2, 3. 3 carbon compound and second carbon containing OH, so that is 2 hydroxy. Right, this is hydroxy group, that is 2 hydroxy. How many carbons are there? This one what we call here is there, see here, CH3CH2OH, that is CH3CH2OH, one of the hydrogen is replaced by OH, that is 2 hydroxy. This is called propanoic acid. Got it? Like that we are giving the IUPAC name for a given compound and also the common name. Remember, the IUPAC name is very important, and also remember common name for some compounds. Now take some more examples. Now take these 3 examples, some compounds, later we will study some more. Now observe here the first one. 1, 2, 3 carbons are there. The second carbon containing double bond. Then its common name is called as acrylic acid. Acrylic acid. Remember the common names for some compounds. This is called acrylic acid. Acrylic acid means CH2 double bond CHCOOH. Then the IUPAC name is, give number 1, 2, 3. Second carbon containing alkene. So that how many carbons are there? 3. 3 means pro. 2E carboxylic, that is one oic acid, that is propanoic acid, oic acid, or we call as 2-propanoic acid, propanoic acid, 2-propanoic acid or prop-2-enoic acid. Okay, now similarly this one observe 1, 2, 3, 4 carbons are there. At second carbon there is a double bond. This is called as crotanoic acid. The common name is crotanoic acid. Crotanoic acid. This is alcoholic acid. This is crotanoic acid. Now similarly write the impact name 1, 2. Second carbon containing double bond. So that this is 2. How many carbons are there? 4. That is but-2-enoic acid. Is replaced by oic acid, that is 2-butanoic acid or but-2-enoic acid, like that. Now observe here 1, 2, 3, 4. 4 carbons are there to write the common name, but this is called as what? Isogroup. Isogroup. Totally 4 carbons is there, hence we called isobutyric acid. The common name is isobutyric acid. Isobutyric acid. Then the impact name is give number 1, 2, 3. This is the longest carbon chain. At second carbon containing methyl group, so that its name is 2-methyl. 2-methyl. How many carbons are there? 3. So propanoic acid. Propanoic acid. This is the impact name, some compounds and also common name. Now take some more examples. Observe. Now we are taking these 5 compounds as an example. These are called dicarboxylic acid compounds. It means there is 2 functional group of COOH. There is 2 carboxylic acid functional group. Now first one is COOH bond COOH. There is 2 carboxylic acid groups right here. Now its name is called as oxalic acid. Oxalic acid. Now observe again after that this one more CH2 group is increases. Between these 2 carbonyl group we are added. See COOH again CH2 and COOH. Then observe this one COOH CH2 COOH COH CH2 twice COOH. It means one more CH2 group is increases. Understand what I am telling here? Then observe the 4th compound. Here there is 2 times, but here 3 times. Then again 4 times. Means 0, 1, 2, 3, 4 CH2 groups. But remaining COOH groups is same. Now this can be observing or remembering like that. That is, see here there is no CH2 groups, 0. Then here 1, 2, 3, 4. How many numbers are there? 5 numbers. That is, the 0 is nothing but ohms. That is O, S, M, G, A. That is called as Ohm's gap. Oxalic acid, sorry, not OS, Ohm's gap. O, M, S, G, A, P. Ohm's gap. There is 6 letters. 1, 2, 3, 4, 5, 6. Ohm's gap. Now again you can write one more. That is COOH bond CH2 4 times. Now write 5 times. Bond COOH. Here 5. Okay. Means O is nothing but 0. M is nothing but 1. 2. S is nothing but 2. G is nothing but 3. 4. A means 4. P means 5. These are the number of CH2 groups. Number of CH2 groups. Now O means oxalic acid. There is no CH2 group. Remember, understanding students, how we can write the common name for these compounds. Dicarboxylic acid, linear carbon chain compounds. Now 0 CH2 group, so that we called as oxalic acid. Oxalic acid. Now only 1 CH2 group, so that M is nothing but malonic acid. Malonic acid. So this is called Ohm's gap rule. See, Ohm's gap rule. Ohm's gap rule. So remember, Ohm's gap is nothing but oxalic acid, malonic acid. Then is 2, that is called S, means succinic acid. Succinic acid. Succinic acid. Then 3 carbons means 3 CH2 group, that is called a G, that is called glutaric acid. Glutaric acid. Then 4 carbons, 4 carbons, 4 means what? A, that is called adipic acid. Adipic acid. Then 5 carbons, 5 means what? P, it is called pimalic acid. Pimalic acid. These are the common name of these compounds. Like that we are remembering by knowing Ohm's gap rule for this carbon dicarboxylic acid compounds. Now coming to higher pack name. Here there is 2 carboxylic acid, right? So that we are using di as a prefix. Before writing prefix, 1 to 2 carbons, the root word is meet. That is meet, methane, dioic acid or dicarboxylic acid. Methane, dicarboxylic acid or dioic acid. Then next one, observe how many carboxylic acid groups are there. Here 2. Then observe here how many carbons are there. 1, 2, 3. 3 carbons means the root word is probe. If there is 3 carbon atom, the root word is probe. Here how many carbons are there? 1, 2 carbon. Therefore the root word is eth. Sorry, here we are writing meth, not meth, eth. That is ethane, dioic acid. This is 2 carbons, 1, 2. The root word is eth, being an alkane ANE. Here no need to remove E. Then use di because 2 carboxylic acid groups. Then oic acid, that is ethane dioic acid. Now here how many carbons? 1, 2, 3, 4 carbons. Therefore root word is prop, being an alkane ANE, propane. How many carbonyl groups are there? 2. That is dioic acid. In dicarboxylic acid no need to write, no need to remove E because we are writing root word first. Then after joining oic acid. Then observe here 1, 2, 3, 4. 4 times is there carbons, so that but. Being an alkane ANE, then dicarboxylic acid, that is dioic acid. Butane dioic acid. Here how many carbons are there? 3 plus 2, 5. So pent, oic acid. But its name pentanoic acid. That is pentane dioic acid. Pentane dioic acid. There is 2 acid groups. Got it? Now similarly here, what we are named for this compound? 2 carboxylic acids and 4 groups. 4 carbons CH2 group. Totally 6. 6 means hexa and an ANE. Then di 2 carboxylic acid. Then oic acid. That is hexane dioic acid. Now similarly for this one, how many carbons are there? 7 carbons. 7 means after hexa, hepta. That is heptane dioic acid. This is the hydropack name as well as common name for these simple dicarboxylic acids. Okay. Then take some more examples. Now we are taking some cyclic compound along with aromatic compound. Now the first one is, see, this is cyclohexane ring, and at 4th position there is a ketone group, and at first position there is a carboxylic acid. For this one there is no common name. Now the IUPAC name is, give number 1, 2, 3, 4 for cyclohexane ring. At 4th position there is a ketone group that is called as oxo group, right? So the IUPAC name is 4-oxo, that is prefix. Then suffix is cyclohexo, that is root word. 4-oxo cyclohexa hexane, that is E is replaced by writing oic acid. That is 4-oxocyclohexanoic acid. That is the IUPAC name. 4-oxocyclohexanoic acid is the IUPAC name for this compound. No common name. Now for this one, this is the benzene ring, this is carboxylic acid. Benzene plus carboxylic acid we call benzenoic acid. That is the common name, benzoic acid. Benzoic acid is the common name. Now the IUPAC name is also same, that is benzoic acid. Benzoic acid, or we also called as, this is phenyl chloride, or we called as benzene. Benzene, this is called as carboxylic acid, that is benzene carboxylic acid. Benzene carboxylic acid. Benzene carboxylic acid is the common name, sorry, not common name, IUPAC name of this compound. Then take this one. 2 carbons, and this is phenyl ring or benzene. Without this one, we call acetic acid right here in place of hydrogen. See, without this phenyl ring, if we are writing in place of phenyl, CH3. What is name? Acetic acid, right? The common name. Now, one hydrogen is replaced by writing benzene ring. This is benzene. Now, what is name? Phenyl. That is phenyl acetic acid is the common name. Phenyl acetic acid is the common name. Then IUPAC name is U number 1, 2. And second carbon there is phenyl ring or benzene ring. So that 2 phenyl, 2 carbon, so that ethanoic acid. 2 phenyl ethanoic acid. Right, got it? Now last one, see aromatic dicarboxylic acid. Aromatic dicarboxylic acid, benzene ring at 2 positions there is 2 carboxylic acid. Hence we call aromatic dicarboxylic acid. Now its common name is gallic acid. Gallic acid. Gallic acid. Okay, this is the gallic acid. Here pH is silent. That is gallic acid. Now the IUPAC name is 1, 2. Give number 1, 2. First and second portion there is a carboxylic acid groups. Before that these two we call, this one we call without carboxylic acid. This one we call as benzene. So benzene 1,2 dicarboxylic acid. That is benzene 1,2 dicarboxylic acid. This is the IUPAC name and common name for some aromatic compound and cyclic compounds, then linear monocarboxylic acid compound and also linear dicarboxylic acid compounds. Then you know how to remember the common names as well as along with IUPAC names. Okay, so here the nomenclature is complete.